Okay, we're going to jump into lesson 24.1, which is on properties of parallelograms. And so we've got a bunch of theorems here that talk about these properties of parallelograms. And I'm going to go ahead and draw a parallelogram here so that we can go ahead and look at this visually as well as in the writing there. So first, parallelogram, that means we're going to have a quadrilateral, so that's four sides. So I'm going to start there. Okay. And then a parallelogram can look something like this, right? And there's a couple of key features here. First, it's got four sides, so it is a quadrilateral. And then we know that these opposite sides are parallel, right? That's why this is a parallelogram. Opposite sides are parallel. Okay, and then we'll get into the theorems that are down below here. It says that if a quadrilateral is a parallelogram, then the opposite sides are congruent. So not only are they parallel, but they're also congruent. So I'm going to go ahead and make a little tick mark here and here. And then these opposite sides here are also congruent. Okay, the next theorem down there says then opposite angles are congruent. So opposite angles are congruent. So that means that this angle here is congruent to this one over here, right? Opposite sides, so they're like furthest away from each other. And then these two angles are also congruent. And then it says, then the diagonals bisect each other. So remember what bisect means? Bisect is that they cut each other in half, right? So if I have a parallelogram and I have the diagonals are the ones that would go from corner to corner here, then they cut each other in half. And we'll talk about how that comes into play in a second. The next thing I want to talk about with the parallelograms is consecutive angles. So real quick, let's first talk about what is a consecutive angle. So if I have got my parallelogram, okay, consecutive angles would be angles that come one after another, right? So they're kind of right next to each other here. So this angle here, and then this angle here, okay, those would be consecutive angles. All right, we could also go in a different direction. I could say this angle here and this bottom one, right? So they're ones that just come one after another. And in this case, for our parallelograms, consecutive angles are supplementary. They're supplementary. So they're going to add up to 180 degrees, and that goes back to our transversal lines and parallel lines, so that's the reason for that. So consecutive angles are supplementary, which means they add up to 180 degrees. So let's use some of these properties here. It says ABCD is a parallelogram. Find each measure. First, it wants me to find AD. AD is this bottom side here. Okay, and so we can set up an equation because remember with our parallelograms, we know that opposite sides are congruent, which means that AD is the same thing as BC. So I'm going to set up an equation there. It looks like this. 7x equals, because it's congruent to the other side, which is 5x plus 19. And now I can go ahead and solve here. So I'm going to subtract 5x from both sides. That'll give me 2x equals 19. Divide both sides by 2. I get x equals, that's going to give me 9.5. All right, and then remember it wants the length of this side here, AD. So I have to go ahead and plug that back in to what I have for AD, which is 7x. Okay, and so we'll go ahead and do that real quick. All right, so then AD equals 7 times 9.5. Okay, and then we can go ahead and get that length there, right? So 7 times 9.5 is going to give me 66.5. All right, so that's finding the length of AD there. Now they want the measure of angle B, okay? Angle B is up there in that top left, right? Angle B is up in the top left, okay, right here. And we need to remember that opposite angles are also congruent with parallelograms, which means that that's going to equal angle D. I know it's hard to see, but this 8y minus 17 is actually angle D. Those are linked together there. It just kind of looks like it's the side length. So if opposite angles are congruent, I can set up an equation that looks like this. 6y plus 5 equals 8y minus 17. And then I can go ahead and solve this thing. And so I'm going to subtract 6y from both sides. So I get 5 equals 2y minus 17. I'm going to add 17 to the left. So I get 22 equals 2y, which means that y equals 11. And then they want me to find the measure of angle B, right? So I got to take that 11 and I got to go ahead and plug it back into y here, right? So go ahead and do that. And we end up here, angle B equals 6 times 11 plus 5. And that's going to give me, let's see, 66 plus 5 gives me 71 degrees. All right, and we'll keep going here. Move to example 2. We've got another parallelogram, so right off the bat, we know that all those properties that we talked about before apply. It says find each measure. First, it wants QR. Okay, well, QR is this side on the right, and we know that that's got to equal the opposite side, so it's the same as what we did in the last one here, so I'll go ahead and do that real quick. We've got 2z plus 4 equals 3z minus 4. Okay, and then I'll go ahead and solve this. So I'm going to subtract 2z, so I get 4 equals z plus, minus 4. And then add 4 to the other side, so I get z equals 8. And then I'm going to go ahead and plug that into my, my z variable here for QR. Okay, and I'll evaluate that. Okay, and that's going to give me 24 minus 4, which just gives me 20. So QR equals 20. Okay, now we get to PR. And PR, they're asking for something a little bit different. We haven't seen this before, right? But we have to go back to one of our theorems here. And remember that theorem was over here. I'm going to slide back over. It says that the diagonals bisect each other. The diagonals bisect each other. So they cut each other in half, which means that this point in the middle here, in this case T, it's cutting this piece PT and RT into 2 equal parts. So those things are getting cut in half, so each one of those things is equal. So I know that PT has got to be equal to RT because it tells me that the diagonals get cut in half. And so then I can set up an equation here that looks like this. X plus 9, that's PT, equals 4x minus 6, that's RT. And now I can go ahead and solve this thing. So I'm going to subtract x, so I get 9 equals 3x minus 6. I'm going to add 6, so I get 15 equals 3x. And then I'm going to divide by 3, so x equals 5. And then I'm going to go ahead and plug this back in here to find the lengths. And so I'm going to plug 5 in for x into both of these pieces here, right? Because I want the whole thing. I want PR, which is this whole entire line. So I want both halves there. Okay, and so when I do that, we'll go ahead and punch those things in. Okay, I'm going to end up with PR equals, let's see, 5 plus 9 up there gives me 14 plus, this should also give me 14 because they're the same, so it does, and then we end up with 28 for the grand total of PR. So each one of those halves was 14, so the grand total is 28. All right, the summary here, it says JKLM is a parallelogram. Name all of the congruent segments and angles in the figure. Explain your reasoning. Okay, I'm going to get you started here, and then you can go ahead and pick up with this. We can talk about it in class here. I just want to go ahead and mark off a few things here. So first, I want to mark off what we just talked about, and that's that these diagonals bisect each other. So that means that M to N is the same as K to N. So those things are the same length. And then same thing over here, we can say that J to N and L to N are the same, right? So those things are getting cut in half, so the diagonals there. We already said that opposite sides are congruent. So these opposite sides are congruent. Okay. And then we know that opposite angles are also congruent, right? So that means that this whole angle, KJM, angle KJM, is congruent to the opposite angle, which is KLM. Okay, and that's these two angles that I just referred to there, opposite angles. And then we also know that these two angles are also congruent. I'll let you jot those down on your own. And then what we didn't talk about is that the consecutive angles are supplementary, right? They add up to 180. So that would be, let's jot this down here. That would be KJM, angle KJM, plus JML, angle JML, equals 180 degrees. And so what I'm talking about there is this angle here and this angle here, right? Those two together are supplementary. They would give me 180, just as the other two on the other side would, right? Or if I took these bottom ones, or if I take these top ones, right? Any two consecutive angles will give me 180. All right, I'm going to stop it there, let you finish that up on your own. Thank you for watching.